Okay, back to the graph of 1 over x. And what I'm interested in this time is the horizontal line here, which happens to be the x-axis. And that guy is a horizontal asymptote. Notice on the extreme left and right sides of the graph gets close to the line y equals 0. This is an example of a horizontal asymptote. Then, in general, a horizontal asymptote guides the graph on the extreme left and extreme right sides of the graph. It has no impact on the center graph. A horizontal asymptote may be crossed or touched by the graph. Now, in this particular one, the graph doesn't cross or touch the horizontal asymptote. That's just peculiar to this problem, or particular to this problem. Horizontal asymptote essentially just tells you where a graph, if it exists, not everything has to have a horizontal asymptote, essentially just tells you where the graph begins and ends. It doesn't tell you about anything in the center. So a lot of times people will say, we'll do a graph and it crosses a horizontal asymptote, and they'll say, but I thought horizontal asymptotes can't be crossed. It's vertical asymptotes that cannot be crossed or touched. Horizontal asymptotes, who knows? It just depends on the problem. Maybe the horizontal asymptote will be crossed, maybe not. It just depends on the problem, because all a horizontal asymptote tells you really is beginning and end. Now this guy, the curve itself is the blue, and it's really only telling us where it begins and ends. It's predicting a sort of end behavior. Beginning of where it begins and ends, it tells you nothing about the center. Now, finding horizontal asymptotes. We're going to use the concept of degree. Remember, degree means highest exponent. We're going to use the degree. So, how to find horizontal asymptotes? Got 3 possibilities. Number 1, if the degree of the numerator equals the degree of the denominator, then there's a horizontal asymptote at y equal the ratio of the lead coefficients. And I'll say what I mean about that in a moment. 2, if the degree of the numerator is less than the degree of the denominator, then there's a horizontal asymptote at y equals 0. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. Then note, again, if the question asks for the equation of the horizontal asymptote, the answer must be in the form y equal number. And that's for me and the computer, that if it says that it wants the horizontal asymptote or the equation, it's y equal a number. So find the horizontal asymptote, if any, of the rational functions. So it's all about the degree. So I look here, and the degree of the numerator, which happens to be 2, is less than the degree of the denominator, which happens to be 3. So I go up here and look at option number 2. If the degree of the numerator is less than the degree of the denominator, there's a horizontal asymptote at y equals 0. So if it says equation of the horizontal asymptote, or just what the horizontal asymptote is, y equals 0. If it asks for just the coordinate, 0. And then these things will check. Now, a disclaimer about checking it, and we'll check it first, then I'll put my disclaimer here. So I'm going to put the entire numerator in parentheses, divided by the entire denominator in parentheses. And then we're just going to hope for the standard window, zoom 6. We'll see what we get. I looked at this problem wrong. Let's pretend this didn't happen. Or we'll just fix it. I looked at it wrong. I mean, yeah, that's okay. We make mistakes. This one's easy to fix. So we'll just pretend it didn't happen, and we'll fix it. Let's read the problem correctly. The degree of the numerator is 2. The degree of the denominator is 2. They are equal. And so then the thing above says if they are equal, the ratio of the lead coefficients. And so in this case, I pick off just that 12 and the 3. So 12 over 3 or 4. And so then there's a horizontal asymptote at y equal 4. And if they just ask me for the y coordinate, 4. And so here, this actually pointed out a good reason to check your work. I made a stupid little error here. I misread this. I looked at the coefficient instead of the degree. Made a stupid little error. But when I went to check my work, it wasn't working. That when I go and check my work, where I'm on the left and right, remember it tells you where extreme left and extreme right, it is at approximately y equal 4. And if I do a little, I'm going to just do a little bit better window, and I'm just going to go from -1 to 6 on the y-axis. And so -1 to 6, and y equal 4, 1, 2, 3, can I do it again? There's 0, 1, 2, 3, 4. Y equal 4 is right about there. And you can see that on the left and right, it's coming close to it. Now, disclaimer. Horizontal asymptotes are about what's happening on the extreme left and the extreme right, and I've only counted from -10 to 10. And so it's possible that if you use the standard window, -10 to 10, zoom 6, that it's not going to show you what's really happening very far out. So when you check these things on your calculator, you need to be aware that when we talk about the extreme left and extreme right, we aren't talking about -10 and 10. And so some people might argue, well, it doesn't really look like it's close enough to 4. Well, if we redo the window, and instead of going from -10 to 10, let's go from -100 to 100. And I count that off by 10s. And notice if I do that, it does really look like it's at really y equal 4. That I counted this from up to 6, and so 6 is at the top, and then 5, and then 4. And so it really does look at it. So there's the disclaimer to checking these things, that if you use the standard window, -10 to 10, that may not be big enough to really make you feel 100% confident that you have found the right answer. But back when I had an answer of y equals 0, that didn't look like that was going to be y equals 0, which let me know that I'd made a mistake. So got a few moments, check your work. Okay, next one. Let's just cover that up. So we'll do it again. That's the same thing as 2x to the first. So the degree of the numerator happens to be 1, and that's less than the degree of the denominator, which happens to be 3. It is 3 this time. And so in that case, that is option 2 up there. We'll put that up there so we can still see it. If the degree of the numerator is less than the degree of the denominator, there's horizontal asymptote at y equals 0 or 0. And we'll check that one really quickly. Entire numerator in parentheses divided by the entire denominator in parentheses. So there, I've got it in there. And we'll go with the standard window because that works very frequently. Okay, we don't see a great graph, but it does look on the left and right. Y equals 0, by the way, that's the x-axis. And so when I look at my picture there, and let's zoom in a little bit so we can look at the picture a little better. On the left and right, it does seem to be on the x-axis. It's telling you about the left and right. Then I see some sort of vertical action going there. That vertical action, if they'd asked me about a vertical asymptote, there's a vertical asymptote x equal 1. And so, but it does check. On the left and right, it's at the x-axis, which is y equals 0. Okay, and let's do the last horizontal asymptote problem. So here we have the degree of the numerator. Happens to be 3. That's greater than the degree of the denominator, which happens to be 1, and when that is the case, there is no vertical asymptote, which means when I check this one, I'm not going to see any, or I said vertical asymptote, I meant to say horizontal. There's not going to be a horizontal asymptote. That when I check this one, what I'm looking to not see, since there's not a vertical asymptote, is that I should see, oops, I typed something wrong. Let's see, what did I type wrong? Oh, I got an extra symbol in there. That when I graph this one, I shouldn't see any sideways behavior on the left and right. And I'm seeing all sorts of weird stuff in the middle, so I'm seeing a really kind of awful picture. But what I'm not seeing is any sideways behavior on the extreme left or extreme right. Now again, I graphed it on -10 to 10, and so maybe that's not showing me the whole thing, but we aren't trying to trick you here. I'm not going to try to trick you by giving you a graph where you would need to graph it from -1000 to 1000 to see what's going on. We aren't trying to trick you. We said no horizontal asymptote, which means on the left and right, I shouldn't see any sideways behavior. I got some weird stuff going on in the middle, but horizontal asymptotes aren't about the middle. They're about the left and right. And on the left and right, I don't see any sideways behavior, which corresponds to the no asymptote. Okay, moving on. For those of you that might end up in some sort of calculus, whether you're an engineering major or science major or computer science and have to take regular calculus, or you're a business major and have to take survey of calculus, you're going to see this arrow notation stuff. And so when I look at this first one, and it says, what this is reading or what it's asking us to do, and it's right down here. This is the same as saying, what are the y values approaching on the extreme left? When it says x approaches -infinity, that's saying look at the extreme left side of the graph. And then why I said y values, remember whenever you plug in x, x goes in, y comes out. F of x is always a y value. So what this question right here is saying is look at this graph over here, and then it's saying what are my y values on the extreme left? That x approaches -infinity, and that is red, x approaches -infinity. It's the left side of graph. And so this is saying, look at the extreme left and tell me what the y-coordinate is. So I look at the extreme left and tell me what the y-coordinate is, and it is an estimate, but it looks like right about there, it looks like that is 1. And so there's my first example of arrow notation. That what we want to get from this first example is when I read x approaches -infinity, that's telling me the left side. And then the answer is always, what is the y-coordinate close to? What is that y-coordinate approaching? And we'll end this video and pick up with the other arrow notations in the next video.